Okay, so we're going to take a little bit of a change of pace today, and we're going to go away from the measurement and the measuring devices, and we're going to look at some algebra. We're going to start out by looking at things like this. Algebra. Yeah. Today we're going to do algebra. Algebra is your friend. How's that? There's two of them for you.
Where did can I have the origin?
So all equations start out like this. There's a variable equals a number. So to understand how equations work, we have to understand this basic form. And to do that, we need to understand this symbol right here. What's that symbol?
Equals.
The equal sign. What does it mean?
Equals.
Oh, it's really hard. Most people say, well, it's equals, right? Well, what it means is what's on one side of it has exactly the same value as what's on the other side. In fact, you can think of it as being like a balanced scale. What's on one side perfectly balances what's on the other side. And as I said, all equations start out like this, as a variable equals a number, or a number equals a variable. And they're built up from there. One of the things we can do to build onto this equation, we might add something. Maybe we'll add 5 to it. So now we have x plus 5. But because this is a balanced scale, if I were to add 5 to it, it would tip. So to keep it from tipping, I have to do the exact same thing to the other side. So I'm going to add 5 over here. What's 4 plus 5 is 9. So what I have here, x plus 5 equals 9, is the exact same equation. I've just built onto it. Now, if you are given the command to solve an equation, what it's asking you to do is to take it back apart. Well, what piece has been built on here? Yeah, we've added 5, so to take it apart, we will subtract 5. That's gone, leaving us back to the just x. But again, because of this balanced scale, whatever we do to one side, if we're going to keep it balanced, we have to do the exact same thing to the other. So we subtract 5 over there. 9 minus 5 is 4. So x equals 4, which is what we're looking for. Now, this one was easy to solve because we built it. We knew exactly what had been done to build it, so now we knew how to take it apart. Not always that easy. We might have something like this. Here, it's already built, so we have to figure out what was done to build it so we know how to take it apart. First step, we find the equal sign right there. We identify where the variable is. Well, the variable's over here, so we're looking at just that side of the equation. And then we ask ourselves, on that side of the equation, what's keeping the variable from being by itself? The 7, yes. And what operation was used to attach that 7? Subtraction. So this equation was built by subtracting 7. How do we take it apart? Add 7. That's gone, leaving us with y. I mean, you're absolutely right, Brennan. Because this is a balanced scale, I have to do the exact same thing to both sides. So I add 7 there. 8 plus 7 is 15. So that gives us y equals 15. If we are unsure of ourselves, we can always double check our answer. Y equals 15 is saying I can come up here and I can replace y with 15. Is 15 minus 7 equal to 8? Yes, it is. Good. How about this one? How was this equation built? This equation was built by multiplying the variable by 3. So to take it apart, divide by 3. Perfect. So x equals 7. You are correct. Now, those are simple, what we call one-step equations. We're going to make it just a touch more complicated. We might have something like this. So on this one, we find our equal sign again, just as always. We find the variable over here. So that's the only variable, so we're looking at this side of the equation. What's keeping the variable, in this case the x, from being alone? The -7 and the 2, right? So the 2 is multiplying the x, the 7 was subtracted. According to our order of operations, what would happen first, multiplication or subtraction? Order of operations, though, would say you would multiply first. So what was done to build this equation is the variable was multiplied by 2 and then 7 was subtracted, right? But if you think about it, you guys are engine people and stuff. If you put something together, whether it's a model or an engine or whatever, and you've just finished, you've just put the last piece on, and you have to take it back apart. What's going to be that first piece you take off? The last piece you put on, right? So the last piece put on here was subtracting 7. That's the first piece that has to come off. So we're going to add 7. That's gone. Leaving us with 2x. Have to remember to add 7 over here. 19 plus 7 is 26. And then we have to get rid of the 2, so we're going to divide by 2. X equals 13. Again, you could double check if you wanted to. You could put 13 up here where x is. What's 2 times 13? 26 minus 7 is 19. Yeah?
Holy shit. I took my senior year again and I finally understood.
Cool.
Yes.
You guess?
Sounds like I got some shit done. None of my first book written by 8th grade.
So on this one, find the equal sign, we find the variable. The variable appears twice. Now, first of all, it's the same variable, which is important for us at this point. Because if it was a different variable, we'd be in trouble. In this case, that variable x, both times it appears on the same side of the equation. So if we're thinking about that balanced scale idea, since they're both on the same side of the scale, I can just push them together and make one big pile. And it doesn't change how my scale balances. So what's 4x and 3x make? 7x. Then we've got the minus 3 equals 18. And now it's just a matter of solving it like any other equation. What do we do next? Add 3. So 7x equals 21. And we divide by 7. So yes, x equals 3.
What do they say the use for algebra is in automotive?
Uses for algebra and automotive, most of them are for like engine displacements and stuff like that. If you're getting like custom machining, custom engine parts, you can get into your torques and stuff like that you have to do and your things like that. But realistically, in the actual automotive maintenance, there's not a lot of math. Basic arithmetic, really. The algebra itself is not really there. Your percentages and stuff you're going to use. But in everyday life, you're going to use the percentages anyway. True. So on this one, find the equal sign, we find the variables. We got a problem. The variable appears twice again, but this time it appears once on each side. So we can't just push them together into a big pile. And you're right, we have to get rid of one of them, and we generally get rid of the smaller of the two. In this case, that would be the 3x. How do we get rid of it? We subtract it. We take it away. It's a positive 3x, so it's gone if we subtract it. That leaves us with just the positive 12, or 12 over here. We have to subtract 3x from the other side. 5x minus 3x is 2x. Why didn't I take it away from the 4? Because the 4 isn't an x. We can only take it away from other x's. So if 2x plus 4 equals 12, and then subtract 4, 2x equals 8, and you are correct. We divide by 2. Hopefully this is a review for most of you. What do you guys think of this stuff?
Pretty easy.
Pretty easy? Okay. There are a couple pages out of your book. 249, exercise 6.1, that'll be 1 through 59, the odds. Obviously, you don't have to do all of those. And page 251, exercise 6.2, 1 through 29, the odds as well. And again, do a couple of the first ones. If they're easy, skip the more difficult ones. Is there a quiz on Monday? Good question. Let me check. There might be. It all depends on how many questions we have to answer on this homework. But yeah, there's scheduled to be a quiz on Monday.